Hey everybody, it's Alex from Engineering Applied. In this video, we're going to be taking a look at the available hole tool found in Autodesk Inventor and how to use that to further streamline our models and our workflow. If you want more easy to understand and practical content made by an experienced engineer like myself, make sure you like this video, subscribe to the channel, and turn on notifications so you don't miss out on any helpful content like this in the future. If you're looking for a specific function, make sure you check the description for timestamps. And if you don't find what you're looking for in this video, check out the other videos in my Autodesk Inventor series playlist because I'm confident you'll find exactly what you're looking for. Let's get started. Okay, so I am currently in a sample part file, and I wanted to briefly talk about why we want to use the hole tool to simplify our design instead of just simply using a sketch and the extrusion command to cut through our 3D geometry. So what you see here in front of you is just a sample of different profiles that we can achieve through the hole tool. And of course, you can achieve a simple through hole or a blind cut with the extrusion command and then using the cut Boolean operation. But the whole point of these lessons is to further improve your modeling skills to the point where we're creating the most efficient and streamlined models as possible. So if we want to change features, we're only changing one instead of going into a sketch and then changing a bunch of different parameters every time you need to make a change in your model. So also, the hole command allows us to achieve some more complex geometry and some standardized cuts based on some standard hardware sizes you might be using in your design. So we can achieve a counterbore, for example, with the hole tool. So we can specify the depth of the step here, the size of the clearance for both the head of your fastener and the clearance area for the threaded portion of the fastener itself. We can also achieve a countersunk profile at the top. So maybe you need the head of your screw to rest flush or below the surface of your part, whatever that might be. You can certainly do that with the hole tool. And then finally, we can add threads to our holes, whether it's just a simple hole here, or I also have threads in this countersunk example as well. So I just wanted to show you this little sample placard first because I wanted to make a point and drive home the reason why we want to use the hole tool whenever possible, if it is necessary in our design. So I'm going to go ahead and just model up a blank placard like this, and we're going to go over how we can use the hole tool in various ways so that we can achieve the most efficient design possible for you. Okay, so we have our blank drawn up here, and so I just extruded a square profile, and we're going to create various hole features using this solid body. But there's one thing that I want to bring up prior to opening the hole command, and that is we have a couple of ways to place holes on a part. We can either create a 2D sketch with some center points and then use those center points to reference the holes onto the part, or we could just click onto the surface of the part and drop holes directly via the hole command itself. So what we're going to do first is we're going to jump into the hole command up here in the modify section, and I'll just give a brief description moving from the top left over to the right and then down of the various parameters, and then I'll show you a little sample of each of these that apply. So up here in the top left, we have our properties tab. You'll notice there's a little X here. If we click that X, it closes the command. We'll go back into the hole tool. The next little thing we have here is the show tabs button. It's a little plus sign. If you click that, we can open various additional menus here. We have our advanced settings menu here, these three little lines. And we have some options in this menu that allow us to control how this tool behaves. So the first option is pre-select sketch center points. So what this does is when you have center points drawn in a 2D sketch, so let's say, for example, we have some center points dropped on the surface, what will happen is when we start the hole command, it will snap holes automatically to that. So let me show you that real quick. So we go to new sketch, and I'm just going to drop some points here. It doesn't matter where they are. Click OK, finish sketch, go back to hole. And you'll notice, because this is not pre-selected, it's not snapping any holes to anything here. But let's go ahead and select this. We'll cancel that and then go back in. Now you'll notice it auto-populates all of these holes in one place. Now, if you know for a fact that most of your hole patterns or your hole features are going to be the same, this is a great way to do it. If let's say, for example, we don't want these two over here on the right. What you can do is you don't have to disable that every time. You can just click this little X here, and then you can just click and drag over the ones you do want, and then it'll leave those alone. And then you can also individually select center points as well if you choose to do that. The next option is keep sketch visible on. So what this does is when we hit this little plus sign, it'll apply the whole settings that we have currently, but keep the window open and then the sketch visible. So let me show you that here. So I'm just going to cancel this. And let's say we only want these top two on the left as a 3/8 by 16ths feature here. So we'll just leave it there. So it's going to thread this in a 3/8 by 16ths, by 16 rather. So we'll hit plus. Okay, so it performs that, and then it moves over to the next holes because I have this pre-select option enabled. Now we can pick a different feature without losing this sketch and having to go back and toggle the visibility settings in the model browser. So just remember that as you work through. So, we could change this to whatever else. It really doesn't matter. So, we could change those whole features and then do that again, and it'll keep it open and then keep that sketch visible. But let's back up a couple steps here. So we're just going to cancel, undo that a couple times. We'll go back into the whole function, and let's go ahead and cancel that. All right, so the next option is window select center points only. So let's say, for example, in your sketch, some of these, so let's add some reference points. So these are center points, okay? We can toggle this option here off of the center point. We could go to point and then drop some other items here. And typically you would use these basically as construction geometry or something similar to that in a way. And so we'll hit OK, finish 2D sketch. Okay, so we'll go back into our whole tool, and we want to make sure this window select center points only is enabled. And so since we have a mixture of center points and non-center points in our 2D sketch, what'll happen is when I click and drag over these, it's only going to pick up the center points. So this is a nice way to utilize both center points and then some reference points in your sketch if you need that, and only select a certain type of point geometry that is in your sketch. Okay, so that's what that option does. Further down, we have hide presets. So if I click this, it'll hide our presets menu. So you saw that little menu disappear. And our presets essentially just allows us to save a whole profile or design profile. We can rename it to a custom name. So maybe I want to do a simple hole that is 0.250 inches in diameter. And I commonly use this. I can actually create a new preset. So I'll just click this little plus sign here, and I'll just call it 0.250 through, because I always want it to be a through hole, and I'll make sure I have my through all option checked. And so this is a great way to save a custom profile. Now, if you go to this preset settings button here, we can save the current preset, rename it, delete it, change our sort order in our menu, and so on and so forth. So we can actually delete this. You just want to make sure whatever it is you're deleting is already pre-selected, and then you just click delete current, and it goes away. So if we'll pull this drop down, we no longer have that preset. So that was the hide presets menu button here. And our final option is single enter to finish command. It's simply put, we just hit the enter key once and it finishes the command. If we uncheck that, then we would hit the enter key. So let's say we're changing a parameter. So let's say we change this to 0.200. I hit enter once, it enters that parameter, and then I hit enter again, and then it finishes the command. I just like to leave it on single enter. It just helps speed up my workflow a little bit, but this is based on your personal preference. And then of course we have our help menu here. It takes you to the Autodesk Inventor help page on the internet if you need any guidance there. Okay, so moving down here, we covered presets. Okay, so you'll notice we didn't cover this up here. So this is the actual whole feature we're creating. We can actually edit the name on the fly, or we can click on the sketch and it'll take us to the sketch of interest that we're using to create the whole feature. So if we click that, we can actually modify the sketch from this window. And then when we're done, so let's say, for example, we wanted to move a hole around, we could certainly do that. And then we can go back to our whole feature, and it does it all in one place. So we don't have to exit out of the command, double click on the sketch. No, that's not necessary. You could do it all in one place. Okay, so moving down here, now we're getting into the meat of the whole types. So Let's go ahead and delete this sketch because I want to show you that you can actually create a hole without a sketch. So we'll just hit cancel. And I'm actually just going to delete this altogether. Okay, we'll go to hole. All right, so there's a little button here, and you'll notice in our input geometry section, we have a positions box. So when this is active, you'll notice a little blue line here. You want to make sure this is enabled by seeing this little blue line, and then we can pick up some spots on the surface. So this little button here allows center point creation on. So it basically creates a center point wherever you click within the command rather than going into a sketch and doing it there. So if you have that toggle, we can just click on the surface and we can drop center points as we need there. It can even reference a center point in this case, it's the origin. So you can use things like that. Now, if you uncheck that, it's not going to allow you to create center points. So if you want to use this tool and you have a habit of accidentally dropping an extra hole where you don't want it, you'll probably want to uncheck that. So again, that's personal preference. We'll just re-enable that. So again, you can create points on the fly, or you can use a sketch. I personally prefer to use a sketch because that flows with my workflow a little bit nicer. I like to position everything prior to making the hole. That way, when I change the position, the hole auto updates. But again, it's your preference. Okay, so let's talk about our various hole types. So what I'm going to do is on each individual hole type, I'm going to cover the various behavior options that we have for those, since those typically change based on your options. So first, we'll start out with the simple hole. It's as simple as it says. It basically is a drilled hole through your part. There's no threads, nothing special like a seat or a step, as if it was counterbored, nothing like that. It's just a simple hole. Okay. And under our behavior section, we get a few different options for how this is terminated. So the first option is a distance. So maybe you want to do a blind distance down to a certain depth. You could specify the depth the hole goes down to. Now you'll notice down here, we can choose the direction. So it's going to default to being cut into the part, but maybe you have a mid plane that you're putting the hole feature on. So if we had a plane positioned right in the middle of this, if you can imagine it sandwiched right in the middle of this part, and we're putting a hole on that plane, we could actually do a cut hole halfway through the part and down to a certain point, and we could flip the direction. So we could either cut to this side or the other side. Generally, you wouldn't want to do that unless a mid plane is significant to the flow of your design. Maybe you're picking up the midpoint several times in your design and you like to use that as a point of reference. You could certainly do that. And we also have the drill point option. So we can either add the drill point in here, or we can leave it as a flat hole. So just depending on your preference and how you want to show it in your model, you could do that there. Now, if you're doing a blind hole that is being drilled with, let's say, 118 degree pointed drill bit, it's a good idea to leave that because it gives you a good visualization of what material is actually left in that space. Because if you're drilling into a thin part, you need to know how much material is between the tip of that cut and the other side of your part. So that's just my opinion on the matter. Again, it really doesn't matter, just as long as you're always accounting for those things at towards the end product. So that's that option as well. Now you'll notice there's these little arrows next to each option. If you click this, it'll just change the selector style for this. So currently it's set to icons. I prefer drop down or icons personally, but you can select drop down if you want. And it just gives you a little drop down menu. We'll go back to icons. Now let's go back up to the termination options for this, because we can also select through all. So if you know, no matter what this part's going to look like, you're always going to drill holes all the way through it, this is a good option. So regardless of the thickness changes that you do to the part, whatever you do, it's always going to drill these hole features all the way through. So if you know that's going to be the case, use the through all option. And then of course the next option is to. So if you use this, you can select a face to drill to. Now, let's say, for example, I wanted to use a reference plane. What I could do is I could do an offset and I'll just drag it, to some arbitrary distance. And then what I can do is I can drop a hole here, select the to option, and then select this plane, and it'll cut down to that plane. So, if you're using reference planes for whatever reason and you want to pick up that reference plane as your distance to drill down to, you can always do that as well. So we're going to go ahead and delete that real quick. Go back into the hole command. Okay, so it looks like we've covered everything in the simple hole. Now I want to move down here and I want to talk about the advanced properties. So if we check the iMate, so let's drop a hole here. If we check this iMate option, it'll automatically assign an iMate property to the hole for use in your assemblies. Also, we have the extend start. So let's actually drop a plane back down again because I want to show you what this does for us. So if we just drop that plane there and let's do a hole feature on this plane, for example. I don't know why you would typically do this. Again, it just really depends on the specifics of your design, but this is certainly there for that. So if I uncheck that, it's going to start the hole from that mid plane and it's going to go down through one side. You know, like I said earlier, we can flip the direction or we could do a symmetric option here. But if we check this, it's going to extend that hole all the way up to the other face on the other side. So again, depending on your design intent, that's available to you as well. Now, let's move back up to the top here and we're going to move over to the clearance hole option. So if we go to clearance hole, essentially what this does is it automates the clearance hole design process for us. So let's say, for example, we wanted to put a number 10 fastener here. You know, we needed a clearance hole for a number 10 fastener. And let's say that we wanted a normal fit. So what this does for us is it allows us to pick our standard of fastener. So you have a bunch of different standards in here. It allows us to pick the type of fastener. So in this case, it's just treating as a flathead machine screw, or we could pick a hex head bolt, just depends on your design. Okay, your size. And then again, your fit. So if we need a little bit less clearance around the fastener, so say we need a really high precision hole cut. So maybe, for example, you're creating some sort of go, no go gauge or some sort of test fixture that has to hold a tight tolerance around those hole features because that's what's actually checking your part. Maybe you'd want a close fit, but maybe it doesn't need to be a super tight tolerance. You just need it to work over a longer distance. Well, then you'd want a looser fit around that hole. So again, this just helps you automate your process for your clearance fits. Now, me personally, I like to design my clearance holes specifically tailored to what machine shop specifications are available for that particular machine shop I'm using, because I always want to make sure in my designs that I have full control over the tolerance that's assigned to the design and how that's actually going to work once the finished product is created. So just a little food for thought there. Let's move down here. We have the same options for your termination and your direction. And then, you know, of course, we can create a custom clearance value if we want to do that. So we could just, you know, let's say we wanted 0.250 for whatever reason. You could certainly do that. All right, so let's go back. Drop a hole there. Okay, the next option is a tapped hole. So it's basically a simple hole, but it shows the threads for your fastener. So let's say I want a 1/4 inch by 20 fastener. We can change the thread direction with this left hand, right hand option. We can specify whether it's a full depth or a blind depth. So if we uncheck that, we could specify our depth for the tapped, for the threads. So let's recheck that. We have our same termination options that we've seen before, direction. Okay, and then we also have our iMate and extend start options as well. Moving over, we have our taper tapped hole, which basically creates a tapered hole that is also tapped. So if you needed one of these in your design, that's certainly there for you as well. Now, let's go back to a simple hole design. But let's talk about the different seat options. So when you have no seat selected, it's just going to be a standard hole. But we can also create a counterbore feature or a countersunk feature. Now, a counterbore feature has a flat step. And you would typically use this if you want to seat a cap head screw or fastener below the surface of a part. So let's say I selected some fastener from a vendor that I want to use, and I need the top of the screw to sit below the surface so that it doesn't interfere with something else being stacked on top of it or whatever else we want to do there. So, you know, that's certainly an option. We can do a spot face, which basically allows us to specify the depth of the of the step here, or the clearance for the top part here. We can specify the opening as well at the bottom. And then we also have the countersink option, which just allows us to create a countersink for our fastener. And so this is for a flathead fastener that is at an angle. So it's really common, at least for the smaller fasteners, to be at an 82-degree angle. Sometimes there's larger angles as well, depending on your loading conditions and your loading properties of your system. So again, you can specify your angle based on your fastener type. You can specify the opening size. And this is just a really great way to automate this process and get the cleanest and quickest design flow as possible for you. One final point I wanted to talk about is that we can also mix and match the seats with various hole types. So let's say we want, instead of a simple hole, we wanted a clearance hole, but counterbore, we can always do that. So, we can size that however we need and combine this with a clearance hole type, or we can switch it to a tapped hole and let's say a countersunk opening as well. So, again, you can mix and match things depending on your design needs. And that just about sums up all of the hole functions and how you would use this appropriately in your designs. That wraps up this segment of the Autodesk Inventor part modification module, where we took a look at the available hole tool. Don't forget to like this video, subscribe to my channel, and turn on notifications to stay up to date on future content that will help you reach your goals along your journey. And of course, don't hesitate to leave a comment or reach out via my website contact page and let me know if there's anything else you'd like to learn about or see on this channel. As always, I love sharing my knowledge and experience with the community, and I'll see you again soon.